Alright, you guys, welcome to E4.1 Hydrogeology. This is video E4.1-1. Very quickly looking at this learning target. E4.1-A. Compare and contrast surface water systems, which are lakes, rivers, streams, and wetlands, and groundwater in regard to their relative sizes as Earth's freshwater reservoirs and the dynamics of water movement. So inputs, outputs to maybe the surface or groundwater system, residence time, how long it stays there, and sustainability is a word used to talk about using water at a rate in which we're not taking more than is ever going into this system so that we're not depleting it and making it dry up. So for these notes, you guys will see that it is just a double-sided piece of paper and it has a couple pie charts on it where we're going to fill some stuff in because we're looking at charts and graphs mainly for this learning target and taking it to this website. So notice in the upper left-hand corner it says USGS, United States Geological Survey. And so this is a government link, usgs.gov. And this one right here has some explanations of where is Earth's water. Generally, Earth is a closed system with all matter, and that includes water in it. So the water is just cycling through the water cycle, which we just learned about. I first want you to look at this graph right here. I'll try to center this on our screen. It says all water on Earth. And the top pie chart, it's brown on my screen, on yours. It says unusable 99%. That's what I want you to fill into that white part where you can see that I just whited it out. So 99% of the water on Earth we can't even use because it's the oceans or seas, glaciers, things like that, other salty water, saline or salty water. We can't use it. And so we have this one little sliver here. My screen is blue, and this arrow should be over here. That is what's usable by humans. So then that one little sliver is made into a whole new pie chart. So we're only talking about 1% of all the water on Earth right now for this bottom pie chart here. And it says 99% of that is groundwater. Okay? That we use, and the rest here is 0.86% is lakes, and then 0.02% is rivers. So lakes and rivers, and then the groundwater. Okay, fill in those percents, and then we'll take a look at this next diagram, the distribution of Earth's water. That is right on the back here. Okay. So really you're only filling in the percents. Okay? And this diagram works from left to right. Alright? See, we're taking each of the next bars is taking a small portion of the one in front of it. So the first column, total global water budget. Oceans, saline lakes, saline groundwater, and so we have just a little bit of fresh water. And this one actually says 2.5% is fresh water. But of that 2.5%, we have 68.6% is glaciers and ice caps. We can't use that. Okay, so almost 70% of it we can't even use. And so then we're down to groundwater and surface water and other fresh waters. So we're going to look at then just surface water and fresh water, and we can see here that a lot of that's ice and snow. We have lakes, and in there we have the soil moisture, swamps, rivers, biological water, water that is in living things. You guys know that humans and most animals are made up mostly of water. And then a very small portion of atmospheric water. So I want you to go ahead and fill in those percentages. And you should continue to study this diagram. You'll see diagrams even similar to this. But you have to know that you're working from that left-hand side to the right. Okay? You have to pay close attention to what it's trying to show you here. First we start at the total global water. Then we're going to peek only at that 2.5% that's fresh water. And we see that much of that we can't use because it's locked up in ice and glaciers. And then we're going to look at only surface water and other fresh waters for this last column on the right. Okay, so this diagram will be pretty important to us. And you guys can do a Google search, Google image search. You can even just type in distribution of Earth's fresh water, or Earth's water. distribution of Earth's water, and you'll get this diagram and similar diagrams. It's a pretty popular one. Another interesting diagram is this right here. It says picture of Earth showing all Earth's water, liquid, ice, fresh water, and saline or salty water. If it was all put into a sphere, okay, so a circle, it would be about 860 miles in diameter. Okay, about the distance from Salt Lake City, Utah to Topeka, Kansas. And that's what would fit. Okay, so we took all of the Earth's oceans, everything, all the surface water, all Earth's water, and that's what it would fill. So think about that for a moment, okay? And if you'd like to even get more information on water, you can take a peek at this chart here, one estimate of the global water distribution, meaning where all Earth's water is. Gives us some pretty big numbers here, though. Cubic kilometers or cubic miles we're speaking. That's pretty big. Okay, so there's not much with this. I really want you just to look at these charts and graphs, because that's how we're going to be talking about E4.1-1 here, where we are comparing and contrasting surface water to groundwater and the various amounts of it. Okay?